Mysteries of the God particle. When the Higgs boson was observed for the very first time, one of the most puzzling things we discovered was that our universe should really not exist. The Higgs boson has a mass of about 130 times that of a proton, which is around 125 billion electron-volts. This doesn't make sense. At this level of mass, the Higgs boson particles which existed shortly after the Big Bang should have attracted each other. This interaction would have forced the universe to contract instead of expand. And if this had occurred, our universe would never have been born. Physicists are at a loss as to why this didn't happen. It may be that hidden laws of physics were at play which we've yet to discover. Or certain undiscovered particles could have been responsible, with dark matter being our #1 suspect in this fascinating cosmic mystery. Dark matter is a theoretical kind of matter said to make up 23% of our universe. If we were to observe dark matter and find out its properties, we may be able to explain why our universe came to expand rather than contract in the presence of the Higgs. One theory which might help us narrow our search is that the Higgs boson sometimes changes into dark matter, or it at least plays some kind of role in its behavior. To prove this, the Large Hadron Collider could be used to measure the energy expelled after a particle collision. If some of that energy disappears, this might constitute proof that dark matter has appeared in its place. Physicists also believe that the Higgs boson could explain why the levels of matter and antimatter in our universe are not as equal as they once were. After the Big Bang, the universe was made up of 50% matter and antimatter. But today, there is a huge imbalance. Matter is overly represented throughout the universe, and no amount of diversity quotas are ever going to change that. When matter and antimatter meet, they have a tendency to destroy each other and in turn create pure energy. But for some reason, antimatter seems to have self-destructed more than matter has. We think this may have something to do with the way the Higgs field interacts with itself. And in order to prove this, physicists plan to observe what happens when two Higgs particles meet each other in the Large Hadron Collider. One final possibility regarding the Higgs boson particle is that there could be 5 types of this mysterious particle, and that the LHC of 2012 simply wasn't powerful enough to detect them all. Today, 2017's LHC is totally jacked and ready for action. But even this may not be enough to uncover the answers to all of the Higgs mysteries. The Large Hadron Collider is attempting to recreate the conditions which existed during the very formation of the universe. This requires an immense amount of power, and it could be decades or even centuries before we become advanced enough to provide this. Or it may be sooner than that, as CERN researcher Elliot Lapellis indicated when he said, "We might come up empty, or we might find a shocking discovery literally next month."